Hey everybody, welcome back. We thought we would do something a little bit differently and talk about a few peer-to-peer myths. We have this little series we're calling Pear Busters. When you're building with peer-to-peer and talking with peer-to-peer people online and normal centralized people, there's a lot of things that people say you can't do, which is obviously a lie. You can do everything. So we just thought we would talk about some of the questions we get asked a lot and kind of give our take on that, which I always think is fun.
Yeah, we're going to be busting them myths.
Yeah, left and right. Peer-to-peer, is that only for file sharing? So obviously not, yeah.
I mean, like in general, a lot of people are using BitTorrent and different things like that, so you get that impression.
Sure. It's also really good for file sharing because files are pretty big in general, and we have lots of them, and we're sharing them, and it's also stuff you want to keep private. And that's actually where a lot of this peer-to-peer technology comes from, like saying BitTorrent. So that's definitely true. The thing is, even though it's very good for this, a lot of data fits this kind of same idea. Like a lot of your data is just files.
If you're sharing files, you're sharing data.
Yeah, so you can kind of take these ideas from file sharing and generalize them. So they're actually applicable way outside it. And I think people just tend to think this because obviously they know about BitTorrent, they know about other peer-to-peer technologies that are just focused around it. The cool things that we work on is we try to generalize these things and make them applicable everywhere.
Yeah.
So that's awesome.
Yeah.
And you talk about that in the Building with Pear series.
Yeah, 100%.
So check that out also. Yeah.
So the data, we can do peer-to-peer data for applications, for bots, for services, for wherever it is we need.
Yeah.
It's all just data.
Yeah, it's all just data, yeah. So another one we get a lot is like the complexity myth of peer-to-peer. Like, is peer-to-peer very complex to build with? Like, software is complex.
It is complex as a start, and the thing is, the whole area has been underinvested in. So.
Yeah, I think that's also why people say this, because it's a very technology-driven field. There's a lot of jargon in there that's hard to understand. What we try to do,
make it simple,
make it super simple, and make it so simple that we know how to do it. And like that we can hire people who know how to do it, and we can have people build it. And also we take all this stuff and then we put it in our runtime to make it easier for people to just get started. And we have a lot of great documentation on there. So it's obviously it's software, there's software development, but having basic front-end skills, you can get really far with this stuff. Obviously, when there's some tuning, you might want to consult the documentation, maybe the advanced section, get a little bit more familiar, but I wouldn't say it's complex anymore.
No, another thing that we're doing to try and make it less complex is using the building blocks rather than APIs. I mean, there are APIs in Pear, and they're going to be very static, but a lot of the rapid iterations are happening in module space. And by doing that, we're making it simpler to maintain applications as well.
And obviously, we always want people's feedback on this also. So, reach out if you have feedback on how we can make things simpler, because that's our mission.
100%.
So another one people talk about a lot is security. Like, is peer-to-peer systems less secure? Because it sounds like people are connecting a lot.
It seems sort of like opened out, like inside out.
A lot of things are connecting to each other. And I actually really like this one because it's one of those very ironic questions. Because peer-to-peer is actually way more secure than existing things. Because when you're in a peer-to-peer environment where you need to have technology that connects people, maybe the people you don't know, to do your data exchange, you have to have really secure primitives. So like encryption on streams and data, that's mandatory, because if you don't have that, bad actors can send you bad data. So you need very strong verification signals. Everything needs to be signed. You need very strong crypto. So all that is baked in, and you can't take that out. So,
but if you're building a centralized system, conversely, unless you go for a very aggressive sort of zero trust approach, then your system is actually more vulnerable. Yeah,
100%. So that's one of the things I really like. You get all the security baked in. We take away a lot of the foot guns about security. We don't allow you to disable it. We kind of bubble it up and say peers are public keys instead of just being some IP, because then you have that encryption. At the core of it, and it's actually way easier to build super secure systems.
Yeah, I know everything comes down to a key, and even like old school days when you had, like, I don't know, some version of Photoshop or something, you needed a key to get the license for that app to use that application. So everything always comes down to a key. We're just going straight to the key.
Yeah, and just saying that's the only option.
Yeah,
100%. Another myth is peer-to-peer slower? It's hard to make performance systems in peer-to-peer. That's a really great one because like obviously we can make bad systems in any system.
Yeah, slow systems are easy.
It's very easy to make very slow systems. I think peer-to-peer, peer-to-peer is great. It's not like a magic bullet that solves everything. If you have two peers and one of them is in Australia and the other one is in Germany, they're just really far away and there's latency involved. And unless we make speed of light faster, there's some trade-offs there.
Sure.
That peer-to-peer nobody else can solve.
There's also the familiarity thing, and this ties back to the complexity thing as well, is that because it's an underinvested space, then, and also because you need a sort of a paradigm switch to understand, how thinking about a centralized system and thinking about a decentralized system requires some slightly different thinking on what's important, even in terms of performance and the end-to-end performance. Like, what does that actually translate to? So there's a shift in thinking that's required. And until you get deep enough into it, you will struggle to build performant apps on your own.
Yeah.
But again, what we've been trying to do is make it easy, so the performance is baked in pretty much.
Yeah, and one of the really cool things about peer-to-peer systems, even compared to centralized systems, is that they have this idea that you keep bringing data closer to you when you're asking your queries and running your database things. So one of the amazing things is that when you run the same queries the second time, which you do a lot because you're reopening the app and like when something changes, only a little bit changed, that's all local. So it's like instant running, and that's where a centralized system just can't compete because there's like no distance between you and the data. So,
and on the other side for us, we have the sparse replication as well.
Sure.
So when you're loading an application, if your application could have terabytes of data in it, but it's only about what the user loads at any given time. So until the user needs it, it won't be downloading it. And after that first time, again, it's cached.
Yeah, exactly. So the cool thing is that we solve a lot of these problems for you. So you just write the applications the natural way you would do, and then you kind of leave a lot of the performance to us with the primitives, all open source, obviously. We love any help we get. And when we make it faster, it's faster for you. But in general, it's actually really fucking fast. Oh, sorry.
In general, it's really fast.
In general, it's really fast. Another good question we got asked is a lot is kind of like about limitations of scale. When systems scale up, especially peer-to-peer, do they hit a limit?
Yeah.
Do I have a network with like 1 billion people? Will things crash down? We just, that's pretty ironic, I think, because it's actually really hard in centralized systems to do that kind of stuff.
You end up needing to use peer-to-peer technology in a centralized system.
Yeah, that's what everybody is doing. They're just hiding that fact.
Yeah.
One of the beautiful things about peer-to-peer is that it kind of scales organically with usage. The more people come in, the more people you have in your swarm, the more peers you have, you can help run your network. Doesn't mean that everybody has to run your network. Everybody's on different devices. If you're on your phone, you have different capabilities than if you're on your desktop. But in general, the more people come in, the better it runs.
You certainly hit scaling thresholds.
Sure.
Where you hit a certain amount of number, you need to figure out how to optimize for that. But it's all essentially an optimization in the end that can be made.
And you need to use the right primitives for the right jobs. We have all those stuff in the Pear runtime. In our documentation, we talk about this a lot. Again, like we talked in another video, it's very easy to make bad systems in any paradigm. But peer-to-peer definitely helps you make these systems where the more peers you have, the faster you can download files, the faster you can upload them. It can actually be a little bit tricky sometimes in peer-to-peer systems if you have no peers, and then you need to figure out a way to bootstrap it. But so the bigger it gets, the better it tends to run sometimes. So that's some very interesting things. So that's definitely a myth. It scales really well.
We benefit from more users. More users don't cost us. They help us.
To add as a simple thing to think about here, I always just like to think about BitTorrent. Think about when you use BitTorrent, how well that runs.
And has for decades now?
Yeah, and you tend to want to sort those things by peers. The more peers, the better it usually runs. That's kind of like the intuitive thing. That's the same thing for our stack. So yeah, that's really, really powerful. So reliability in peer-to-peer systems. Meaning like, do every peer need to be online all the time?
Nope.
Nope. Next one. And what's the things there? Yeah, obviously, it's a really good question. I get asked that a lot. It's kind of like, if I'm running Keet on my phone, do I then need to have Keet on all the time and go around with it all the time to receive my messages? You definitely do not. Peer-to-peer doesn't mean that everybody's running all the time. It just means that everybody has the same capabilities. Unlike a central system where if you turn it off, nobody can do anything. In a peer-to-peer system, as long as somebody's online, you can do almost everything. And if nobody's online, you can do a lot of stuff offline. So it's kind of like one out of many instead of one central point of thing.
I think a lot of centralized systems try to achieve the goal of high availability and also like the closest to immediate consistency as possible.
Sure.
But the trade-off always is that you want to go eventually consistent.
Yeah.
And that means we make that trade-off explicitly. Therefore, availability is not a big deal.
No, and it's even so little of a deal that you can do all this stuff offline. So if you're like, in a plane or whatever, you can still write messages in a chat app. You can even do a little network without people in there just to have your own little network running because you don't need everybody. So I think it's one of the biggest strengths for peer-to-peer is the reliability. And it's one of the things where it's in practice just unkillable. And that's why we say unstoppable a lot, because it is unstoppable. And as a person developing peer-to-peer systems, whenever you make a bug and you deploy that and you try to stop that from spreading, then you realize how hard it is to control these systems in a good way. And the good thing then is when you make a fix, it spreads just as fast. So it's very, very doable and very, very, very powerful. Usability. I think usability is something we get asked about a ton. Something that comes up in a lot of Twitter threads. It's something I came up when I did a lot of conferences talking about it, because peer-to-peer, when we talk about peer-to-peer, we talk very technical. We say technical words. We say encryption, we say hole punching, we say networks, we say UDP, and it tends to get very technical. And I think when people hear that, they start to think technical and they think, oh, this sounds very complicated. The beautiful thing is it doesn't have to be complicated.
No, it's actually quite intuitive.
Yeah, it can be super intuitive. You can, as a developer, you can just choose to hide all this stuff like you would do with any other good app and just make a great app. I think a good example of that is actually Keet, which we make, which is just tries to be a chat app. It's peer-to-peer, it has all the goodness of peer-to-peer, but it's just a little text interface beautifully designed where you just add stuff and it gets out of your way.
I guess there is a slight nuance to it with the usability angle in that when you're sending, say, a message to someone, the person needs to be online, say it's like a large file or something like that. So then you do have to sort of think, okay, well, if there's a large amount of data that needs to go from one peer to another, those peers do need to be online. And so sometimes there's maybe like a little bit of UI that's needed around that or something creative.
You definitely sometimes need to think in the P2P aspects.
Yes.
And because they don't behave 100% in the same way. But it definitely doesn't have to be technical.
No.
I don't think what you're saying there is technical.
No,
it can be really clear and intuitive. And for most users, they wouldn't even notice. And for a lot of the other stuff, it tends to be things that they are naturally known by, i.e. if you're sending something big, you need to be online while sending it. And the UI should obviously inform you of that. The fact that it's not going to a server doesn't really change the usability there.
No, but this slightly different way that peer-to-peer work, well, quite different way that peer-to-peer works versus centralized systems, means that I think there is, new ways of using or having apps that work in a different way that's actually better than what we have currently.
100%.
But it's a case of familiarity and like getting people to move to these new paradigms as well. It's going to take time, but like I think ultimately technology gets easier.
Definitely, and it's for everybody.
Yeah.
So a good myth about peer-to-peer is about, first of all, storage and about security around storage, meaning, you have, peer-to-peer is all about moving data around. So you have a lot of data coming to your phone, which means it's on your phone.
Lives on the device.
How to tackle that. Does that mean that my device will run out of storage, for example? It will not. Like with any other thing, it definitely can. If you just fill it up with a ton of junk, it can. The cool things about the primitives we build is that, and I think we touched about this in another video, but it utilizes this thing called sparse replication, which means that the amount of data you actually need to download to do your job in the applications is very small. even though that the peer-to-peer data structures can have a ton of data.
Yeah, you can have terabytes in an application, but the user might only need bytes or kilobytes.
So, for example, if you have a Keet room where people are sharing terabytes of video, which you can do, which is awesome, and it's like 1 billion messages long. When you're just loading and reading a last message, you probably only have like a couple kilobytes of data because it just needs to get enough peer-to-peer data to just show that. And that's it. So it's not like peer-to-peer is just filling up your disk or anything.
Yeah, there's not all the state's not going to every single device.
And one of the really cool things about this, by having that data, is that once you have that data, because it's like peer-to-peer verifiable in the data structure, you can share the data with other people, and they don't need to care that it's coming from you because the data is always verifiable through the data structures. So it's actually a huge feature that you get a little bit of data, because it means that if you and I are chatting, and we're also chatting with our friend in Australia, we can just replicate between each other super fast and efficient, and very good for the environment also, because it's not going all kinds of places, and just good for UX because it's fast, while getting a little bit of data from our friend there. So it's kind of like you can always choose the shortest path, which this stuff kind of gives you. And also kind of tells you about the security myth, because that basically means that it's all verifiable, it's all signed, and it's all secure on your device that way. So it's
every stream is encrypted between devices.
Everything is super encrypted. It's encrypted also at rest. So unlike a lot of other stuff.
When you say encrypted at rest, the data on the device is encrypted.
Sorry, I'm a developer. I'm good at
breaking it down.
Yeah, that's great. And this is all non-configurable, unlike tons of other stuff. So when we won't have data leaks because it's all like always
any data leak that occurs would be a user leaking their own data, and it would be that one user. It would be, which could happen anyway.
It would be encrypted.
Yeah, it would have to be something that would be like taking a picture of a screen of a device or something.
So there's not like a central place where all the data is. It's all spread out. It's all end-to-end encrypted. It's all encrypted on device, and that's the feature because it means we can spread it around in the swarm. Super secure. Again, you can't disable this. It's always on, and that's a huge feature. And that's why, as a developer, also I think it's much easier to develop secure products with peer-to-peer technology.
We also do a thing called blind mirroring. That's where some state is actually stored.
Well, that's actually a feature because of this. Because everything is encrypted with strong encryption, you actually can just have other people host your data because they can't use it for anything. It's just kind of like gobble.
So the security enables scalability.
Exactly. That means that other people can host your data, you can host other people's data, and nothing is lost from that, and just helps the network. So yeah, it's hugely powerful by just baking these things in.
We're green.
We got the trees. Let's talk about energy efficiency. I think that's something.
This is an exciting one.
Yeah, and it's also something we talk about a lot in our time, and it's always important. Is peer-to-peer energy efficient? Well, it's like the thing about a centralized system, first of all, is it's kind of like that factory you never see, but it's somewhere. Like those things are huge, and they're putting in tons of power and heat and stuff like that. But you tend not to think about it because you're just using your device. Yeah,
but if you've gone round a little bit and you've seen how the sausage is made, you see how much power is going into that.
I think a cool thing about peer-to-peer is like there's no the sausage in your hand. Basically, like you have your devices. So you kind of know what's going into it. There's no tricks.
It's just device to device. If you have device to central server to device, you're eliminating that other piece. So you're eliminating all the cost of that piece.
Yeah, and so it's kind of like it's very transparent. I think to a big degree that it's easy to understand what's going on as a consumer. Obviously, you're using infrastructure from your internet provider and stuff like that. But that's. If we could not do that, we would not do that, obviously.
Oh, we'll see.
We'll see, so it's super transparent. You have your devices. You don't have to buy new devices. Those devices are very, very powerful. The phones we have today are insanely powerful compared to 10 years ago. Laptops are powerful enough to run tons of peer-to-peer stuff. We don't need any new technology. Any new hardware. Because we all have it all we need. We could talk about a little bit this in the previous video. But P2P also likes to move data close to each other. So if you and I here are sending a message, if we took out our phones and sent a message on on Signal or WhatsApp or whatever. That message
go all the way
some data center, who knows where, and probably be relayed. I don't even like the efficiency of that is like hard to say that's not like.
It's not the most efficient.
It's not the most efficient. If it's peer-to-peer, it's just like you and I.
One device to the other device.
We just send it here.
If we're on the same network, it's even going through the same
network. We just literally just go here. So there's no denying that. That's like just a very simple fact to think about. Is super efficient.
And then if you scale that up to the whole planet, you take everyone that's doing everything that they're currently doing through centralized services, and you just say, let's theoretically change that all to peer-to-peer, what would the energy savings be? I think that'd be pretty massive.
Yeah, I think so also, definitely. So definitely, I think that's a super interesting angle, and if anything, it's not a myth, it's something that's something we should look more into in the future, and I think it's going to be super important.
Exciting.
Yeah. Internet dependency. Do you need to have internet on your device to use peer-to-peer technology? Do you need to be connected to everybody to have peer-to-peer technology?
Technically, no. I mean, you could use Bluetooth, couldn't you? Or something like that. You could use something that's like hopping between.
So peer-to-peer doesn't really care how you move data around. It just wants to move data. It also doesn't care if you move data around at all. Like you could just be fully offline because peer-to-peer doesn't have to talk to servers. It just talks to your device. So obviously, if you're in a chat and you're offline, that's not the most interesting chat. I mean, we like talking to ourselves sometimes, but we're also just, talking heads. But it totally works, right? So it's like you can still write messages and be like, oh, I'm queuing these for later. And the peer-to-peer system doesn't care. And then when
you are online,
that starts to sync. And that's a huge feature, and you don't have to think about that.
It's sort of a workaround of the availability problem in a way, because you don't need the availability to interact with the UI or the state of the device or of the application.
It's actually, I think it's a really interesting thing, because we're privileged to live in areas that have very good internet and very little outage. I recently did some travel over Christmas, and it's funny how hard it is for your brain, even though I make peer-to-peer things, to get used to the fact that when I take out Keet and I send a message in an airport on some crappy hotspot, it's the same experience as when I'm home, because for me, the messages are just added to the peer-to-peer data structure. They're probably syncing a little bit slower because the network there is terrible. But then I had the same experience where I had to send a message on Slack, and I got that message of, you can't send it because the internet is not good enough. And it just gets in your way.
You can save one draft, but that's all.
And it's like this error scenario. So when it's peer-to-peer, it's just it just feels natural. There's no difference. It feels exactly the same on fiber as it did in the airport. And I think that's actually one of those things where in the future, once I got used to that, it's so hard to go back. And that's one of the powers of peer-to-peer. So it's and also, of course, no account. Yeah, of course. So you don't have to, log into have a password and you can do it all offline. All of it you can do off. There's never any time where it's you have to be online.
Yeah.
So